Hey class, Mr. Houston here. Today we're talking about Chapter 12, Lesson 4, Probability of Disjoint and Overlapping Events. Alright, just a quick vocabulary lesson. Disjoint means two events that really have nothing to do with each other. They have nothing in common. Whereas overlapping means that they will have some sort of their probability is in common. So we're going to take a look at those two today. So, anytime we're finding the probability of compound events, we have two equations. You have the first one. If A and B are any two events, then the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Alright, and then if we're talking strictly disjoint, so two disjointed events, so they have nothing to do with each other, it's just the probability of A plus the probability of B. We're going to put both of those into action here today as we try to solve some of these problems. So the very first one, card is randomly selected from a standard deck of 52 cards. What is the probability that it is a 10 or a face card? So if we're writing this out, we're doing the probability of 10 or face. So we are going to be using the second formula up there, where we're just going to take the probability of getting a 10 and we're going to add it to the probability of getting a face card. There are 4 10s in a deck out of 52 cards. And a face card, if we're talking about a face card, you're talking about a king, queen, or jack. So there's 3 in each suit. There are 4 suits, making there 12 total face cards. So we end up with 16 over 52, which we always need to simplify that. And when you simplify 16 over 52, you get 4/13. So the probability is 4 over 13. Alright, okay, so then let's do the standardized test practice. Just wants to give you the opportunity for A, B, C, and D. So a card is randomly selected from a standard deck of 52 cards. What is the probability that it is a face card or a spade? The key here is understanding that you have face cards that are spades, so this is an overlapping event. So we're going to need to know the probability of a face. We're going to need the probability of a spade. We are also going to need to know, we need to also know A and B and A or B. So probability of A, or let's choose what we actually know. So probability of face and spade, and the probability of face or spade. This is the one we don't know. That's what we need to figure out before we can do anything. Alright, so let's take a look here. Probability of a face card doesn't change. There are 12 total face cards. There are 52 total cards. Probability of a spade. There are 13 out of 52. Now, they need to know a probability of a face and a spade. There are 3 face cards that are in the spades. So we would have 3 over 52. And to figure out a face or a spade, we simply would take the probability of a face plus the probability of a spade, but then we have to subtract what they have in common. So we would subtract 3 over 52. So what that will net us here, 12 plus 13 is 25. 25 minus 3 is 22. So 22 over 52. And then to simplify 22 over 52, we'll get 11 over 26. So that would be letter B. And that's how you find the probability of an overlapping event, right, when they have something in common. Let's put that into further use here. Out of 200 students in a senior class, 113 students are either varsity athletes or on the honor roll. There are 74 seniors who are varsity athletes and 51 seniors who are on the honor roll. What is the probability that a randomly selected senior is both a varsity athlete and on the honor roll? So let's figure out everything we know here. So we need the probability that they are an athlete, probability they are on the honor roll, probability of A and athlete and on the honor roll, and the probability of A or the honor roll. So let's fill in everything that we know here. The probability that we have an athlete. There are 74 seniors that are athletes. Probability they're on the honor roll. That's 51. We don't know. That's what we're trying to find here, is the and. So we'll do a question mark here. And then A or was up here, and that's 113 over 200. So the formula would give us 113 over 200 is equal to 74 over 200 plus 51 over 200 minus what we're trying to find, and it's going to be over 200. So the easiest thing to do, so we're not dealing with fractions the entire time, is because they're all over 200, we're just going to get rid of the 200 for right now. It's not going to serve us. It's not going to do us anything different. So now we're just solving 113 equal to 74 plus 51 minus x. So 74 plus 51 is 125. We're going to subtract that 125 on both sides. We're going to get negative 12 equal to negative x. Obviously, we're going to divide by negative 1 on both sides, and in this case, x equals 12. So there are 12 students who are both an athlete and on the honor roll. All right? Let's go ahead and flip over to the next page. So after all that hard work on the front, now we're going to talk about what it is to be a complement of an event. And it's very simple. You take the probability of an event, and you're just going to take 1 minus that probability to find its complement. All right? So let's take a look here at an example. So when 2 6-sided dice are rolled, there are 36 possible outcomes, as shown. Find the probability of the given event. So they want to do, part A is the sum is not 6. Okay? So if we want the sum of not 6, we're going to take 1 minus the probability that the sum is 6. So if we look up here, we find 6's. I'm going to highlight them every time I see them. So here's a 6, which means there's a 6, there's a 6, there's a 6, there's a 6. That should be all of them. So we already know that there are 36 possible outcomes. 1, 2, 3, 4, 5 of them add to 6. So 5 out of 36. So to figure out the probability that it is not 6, basically the easiest thing I can tell you to do is just take 36 minus 5. You're going to take whatever this bottom number is, subtract this top number, and that will give you the complement. Because essentially what you want to do is be able to add the not 6 and the 6, and they should add up to 1. So 5 over 6 plus 31 over 6 will give you 36 over 6. Okay? Part B then wants the probability the sum is less than or equal to 9. So probability that the sum is greater than 9. So we can go through and count. We're going to do all the ones. We're going to do 1 minus that the sum is less than or equal to 9. So if we do that, we'll highlight in a different color this time. Less than or equal to 9. So these are all less than. These are all less than. We're going to keep going here. 8, 9. So we're here. And we just keep going. So really, in this case, it almost makes sense not to do that. Because we only have 1, 2, 3, 4, 5, 6 times where it's going to be greater than 9. So you could have done it either way. But since we already counted, there was 30 out of 36 times that it was less than or equal to 9, which means the probability that it is greater than 9 will be 6 out of 36, or 1/6. Okay? So again, just simple subtraction in order to find the complement. And we are going to skip this last problem. We're not going to talk about it on the video. Maybe we'll talk about it in class. So you've learned how to find the probability of compound events and complements of events. So if you have any questions, bring them with you to class, and we'll see you then.